Okay, so this first part of this question says Mary and John took out a mortgage of 400,000 to buy a new house. They agreed to repay this loan plus interest by a series of equal monthly payments starting 1 month after they received the loan and continuing for 20 years. The effective annual interest rate is 6%. So the first part just says show that the rate of interest compounded monthly corresponds to effective annual rate of 6% is 0.487%. So it's a very straightforward standard first part of financial maths question. So we'll do this pretty quickly. Now I've done a video obviously previously on this if you want to check it. But what do I do here? Well, I need to fill in this compound interest formula to match to equate 6% to a monthly. And how I do it is this: I pick a final amount that is 6% bigger than the principal amount. So if I pick a principal to be 100, then I can say the final is 106 because that's the easiest one to think about for me. So I definitely know 106 is 6% bigger than 100. And that will work for any percentage if you pick P to be 100. Now, what do I pick I to be? Well, that's what I'm looking for. Now, T. I know that it takes 1 year for this to happen. But of course, I want my interest rate monthly, so we're going to change that to 12 months. So we have the information we want, we just have to get this I. So F equals to 106, P equals to 100. 1 plus some I to the T, which is now going to be 12. So a small bit of rearranging, let's bring over the 100 first. And we get 1 plus I to the 12. You need to get rid of this, you need to get to this I, so you need to get rid of that 12. So we actually get the 12th root of the left hand side. And that's equal to then 1 plus I. And then when you get this, which I will leave as this here, and you bring over this 1, it's subtracted, you get equal to I. If you do all this on a calculator, you should get, so I have this button here, big 12, and in here then I put 106 over 100. Come out here and subtract the 1. What do I get? I get 0.0048, and then made this in place we're going to three significant figures. So it actually goes 6, 7, so that rounds to a 7. So 0.00487, which of course is 0.487%. That's the first part done. So part 2 says show how to use the sum of a geometric series to calculate the monthly repayments that they make on their mortgage correct to the nearest cent. So we know that using a geometric series, a mortgage can be represented as this: each payment made over the 1 plus I interest rate, so a rearrangement of the compound interest formula, effectively finding the present value of each payment. Okay? So if we look at what we have, we know that we have our monthly interest rate I now from the previous part to be 0.00487. We have to calculate how many years they're going to make this mortgage for. So N is going to be, it says 20 years, so 20 multiplied by 12, that's 20 years, right? Gives us a total amount of 240 months for repayments. So when we look at this, we can tell that each of these is going to be some payment A over 1 plus 0.00487. Yeah, and then to different powers as we go along. So the first one would look like this to the 1, and then the next one will be the same payment A again, and it will be over 1.00487 this time to the 2, all the way up to the very last one, which would be A over 1.00487 to the 240. Right? So when we look at all this, we can see that all of these things here must add up to the total mortgage amount, which is 400,000 euros. So let's concentrate then on the geometric progression. And what are we trying to solve for? Well, we're trying to solve for that A, aren't we? So looking at that, I could take an A out of what's in here and rewrite this stuff in the red box as this, as A outside and inside 1 over 1.00487 plus 1 over 1.00487 487 this time squared, and so on to the last one, which is 1 over 1.00487 to the 240, and all that stuff's going to be equal to my sorry, it's a bit of a mess, 400,000. Okay, so actually all I'm actually concerned about here is this stuff. I want to get the Sn of this stuff because this is a geometric progression here, and in a geometric progression we have Sn is equal to a 1 minus r to the n over 1 minus r. So let's look at this stuff in the square brackets. What have we got? Well, we have a first term, a, and a is 1 over 1.00487. And we have a ratio. Well, we multiply by this again to get to the next term. We also multiply by this again to get to it over something cubed. So the ratio is the same. And then for the n, how many terms are there? Well, we know since we're starting at 1 here, and it goes up as far as 240, it must be 240 terms. So when we take this into account, we can fill in our Sn formula. We have our a, which is 1 over 1.00487. That's going to be multiplied by 1 minus that ratio, 1.00487 to the 240. And that stuff's going to be all over 1 minus 1 over 1.00487. So definitely something tricky to enter your calculator, but my suggestion is always to take this top part here, do this into your calculator first, and then get this answer divided by this stuff in brackets. So I'll try and do it on the calculator so maybe be able to see it here. So I'll do the very top line first. So that's 1 over 1.00487. Okay, brackets to multiply by 1 minus, and in brackets 1 over 1.00487. But this stuff is to the power of 240. Let's not forget to close that final bracket. Let's hit equals. Now we'll divide that by brackets 1 minus 1 over 1.00487 equals, and we get this amount of 141.35. So this stuff is equal to 141.35. But of course I know that's not what I'm looking for yet. Where am I down to now? Well, essentially I'm down to this. I look at this equation here. I now, instead of having a times all this stuff equal to 400,000, I have a times now 141.35 equals to 400,000, and that means a must be equal to 400,000. This guy coming under. So what do we get there? Well, let's do 400,000, another one, over 141.35. See what we get, and we get 2829. And to 2 decimal places, well, 0.85. So that's it. That's that part done. And the last part then says use amortization to verify your answer. So amortization is a word always used in loans and mortgages. It's kind of a given formula, and in fact if you weren't asked to show how to calculate this payment using a geometric progression, you could have just put all these numbers into this, which we'll see now. It would have given you the same answer. So we have to just verify the answer we just got. The amortization given in your logbook is the payment amount is equal to the principal amount times the interest rate times all this stuff and the time. Always make sure that this interest rate and time matches. What I mean by that is, if you're given an interest rate in monthly, make sure your time is in months. Whereas if you're given an interest rate yearly, make sure your time is in years. Usually you'll be given two different ones, and that normally means you have to change the yearly rate to a monthly rate, or maybe change the time back to months or something like that, which we had to do both of here. So we just have to literally put all these numbers into that formula and see does it work. So what does that tell us? Well, A, which is going to be the payment amount, is going to be equal to P, that's 400,000, times the rate of interest, which is 0.00487, 1 plus 0.00487, to the time now, which is going to be 240, all over 1 plus 0.00487. 487 to the time, which is 240 minus 1. Let's go through that nice and slowly in our calculator. So again, I'd probably suggest to do this the same as the last way. To avoid making a mistake in our calculator, we'll do the top line first, and when we get that answer, we'll divide it by this stuff in brackets. So what you'll do here, so let's go like this. So 400,000 at the front, multiplied by first point 0.0487, and let's close those brackets, and then more brackets 1, and then you can just do 0.00487 and close that bracket, put that to the power of 240. That's the top line done. Let's press equals. Now we have an answer. We're going to divide that answer by, and let's open a bracket again, and then what have we got underneath? So we have, let's do 2 brackets because we want to calculate this stuff to the power of 240 before we subtract the 1. 240. So we have that stuff there, and now subtract the 1, now close the bracket. Now we're dividing by all this operation here, equals, and we get 2829.84. So that's equal to 2829.84. Yeah, I did get 2829.85 above. I'm a cent out, but I think in the general scheme of things, I am definitely not going to lose any marks for that. So that's the 2 questions done. I suppose the first thing you had to be careful of was finding that geometric progression for your mortgage. So I'll see if I have it here. If you had to take one thing from this video, I suppose, is to remember this. It's very similar to a pension question for finding the pension amount, which I'll put a link to up here. So maybe have a look at that if you're unsure how I made this sequence. But I may, I'd say go back over this again and find another similar question and see can you get it out. But this stuff in purple, that's something you should try and remember if you have to do this question again. So on to the next part. And the next part says after 2 years of paying their mortgage payments with no problem, their financial situation worsened and they were unable to make any further payments. So using amortization or otherwise, it says find the amount outstanding immediately after they made that last payment for themselves. So their payments were $2,829.84. They had 2 years payments made, 24 months done. They had a total of 2 years, of 20 years, sorry, to pay the mortgage. That's 240 payments minus 24 they had done, leaving 216 payments left. Okay. Now the amortisation formula is this, and they have told us in the question, gives a hint that we can use this. How are we going to use this? Well, remember in the amortisation, this is your monthly repayment amount. This is the amount you would borrow, and these interest rate and time. We actually know the monthly repayment amount. We know the monthly repayment amount to be what we have up here, 2829.84. We know the interest rate is not going to change. Sorry, it's 0.00487 if they were to stay on that path. And we know time-wise they have 216 months left. What we're going to do with this information is put it in here and find out with this information, fill in what actually would the principal you could borrow be using that info. And that actually must be the amount of money outstanding. So that means that we're going to change A to 2829.84. And in general, I really do recommend, it's always a good idea to, when you write your formula out, write this little key here of each number. It just avoids you making any unnecessary errors. So P is what we're looking for this time, and I of 0.00487, and that is then 1 plus that I, which is 1.00487, to the T, which is 216, all divided by this stuff is 1.00487 to the T again, which is going to be 216, and that's going to be minus 1. So how do I recommend you do this? Well, I actually probably would leave the left hand side alone and maybe just leave P here and calculate the top and then the bottom line. I'll write this in just to avoid confusion. 2829.84. Now P is going to be multiplied. Let's put this just one number on top, one number on the bottom. So the number on top is going to be 0.00487 multiplied by, and that's 1.00487, and this time to the power of 216. I always forget a 0 in here, so just be super careful. When we do that, we get this number on top of 0.0139, and that's going to be over. Now I've cut that down to 3 significant figures there. So underneath, we're going to get 1.00487 and 216. Now if you're competent on the calculator, definitely try and do it all in one go, because by me cutting down to significant figures, I am actually increasing my margin of error each time. But because we're in money, we go to 2 decimal places. I should be okay. It may be off by a cent as you saw in the first part, but in general it's okay. Just for money, not in general, sorry. 5584 on the bottom. Now when I look at this, a small bit of rearrangement will tell me that I have on the left hand side now 2829.84. This guy is going to come up beside him, and this guy is going to go down underneath. So it's 1.85584 all over that 0.0139. That's all equal to my P, which I'm looking for. Actually, I've left my last answer on the calculator, so I'll just multiply that by 2829.84 equals, and I'll divide him by 0.0139, and I get an answer of, it's money, 377,822.81. Now as I said, like, I've definitely cut that down a little bit, so especially when I cut this down to 3 significant figures. In general, you probably should do it in one go, but to those of you that might struggle with a calculator and may get nowhere near this answer, try this. I think the official answer from the marking scheme is actually 377,600, or in or around 606 or something like that. So look, try that. I mean, I've just simplified the calculator work a bit just to help you through it, but try go through this more properly and see if you get down to this answer. And that's that part done. Now we're on to the final part. It says that their lender is going to charge an additional rate of interest of 1.5% per year on the outstanding amounts of loans in arrears. Now, how long will it take for the outstanding amount that Mary and John owe to exceed the original sum of money borrowed? So let's remember that the original sum was 400,000. Now, this is a lot easier than you might think. Basically, they can make no more payments. They can pay nothing. And that money's going to be sitting there, accrued interest. What kind of interest? It's compound, standard compound interest. What am I talking about is this formula. FP1 plus I to the T. The formula we're always talking about, except in its most basic form. So, if that money sits there, and this is going to be the interest rate that they're charged, 7.5% per year. Now, how many months? We're going to break that down to monthly. I haven't done this here because I've done it so many times now. It started this video in a previous video just doing this. You should be well able to do this now at this stage. So, accruing this much interest per month, when is this amount going to overtake that amount? Well, you know what we'll do? We'll set them equal each other. We'll see that how many months will it take for this stuff to be equal to 400,000. So, when I say that, I stick the final value in as 400,000. I put in the 377,606, right? 1 plus the 0.00604. Remember, always change this to decimal. And we don't know about how long that's going to take. So what I'm trying to do is this. I'm trying to solve this equation for t. It's going to tell me exactly how many months it's going to take for this stuff, this money, accruing this interest to equal this. So, a small bit of rearrangement. Hopefully you're able to do this. If you're able to change this from yearly to monthly, this will be no problem to you. 377,606 is equal to now 1.00604 to the T, like so. Now, how do we get down this T here? Well, remember, as a side note, right, that we were getting like 12 to the root and stuff, but we don't know the T, so what do? Well, this is a very similar problem to this. Like if 8 was equal to 2 to the x. Well, what 2 to the power what gives you 8? Well, you may know it's 3, but we use logs. We use log base 2 of both sides there. And that kind of gets rid of that stuff there. Log base 2 of 8 is 3. So this is unfortunately using logs for some E, but logs are absolutely lovely to use. They're easy. So what's the base of this power that we don't know? It's this 1.00604. So we must get the log base 1.006 0.04 of this side. Okay, now when we get the log base, this stuff, this side, it's just going to get rid of this stuff. It's just going to bring our t down like so. So when we put this stuff here into a calculator, what do we get? Well, let's do it here. So log this button here, and the base is 1.00604. What's in here? 400,000. And underneath 377,606 equals, and I get 9.56 is equal to t. That means that it takes 9.56 months, because remember that's what t is equal to months, because my interest rate was in months. So it takes 9.56 months, right, to get there. But of course we're only talking about on each month. So actually it's on the, it's going to take 10 months for it to exceed it, because we have to pick a month that it's going to exceed it. We're not going to say 9.56 just above that. It's not on the 9th month, it's not going to be above it, it's still going to be below it, because we know somewhere in between the 9th and the 10th months, that's when it gets equal to 400,000. So after this term it starts getting bigger. So that means on the 10th month they're going to notice when they get their statement that they're going to owe more than they originally borrowed. And then in the very last part of this question, it says, give one justification as to why Mary and John's lender would charge a higher rate of interest on these loans. So, I suppose you're not going to learn that in any books. Maybe if you're doing economics, maybe it might be easier for you. So, why lender charges, let's say, a penalty. Well, there's a couple of reasons. So you could say that more admin that's definitely one. More staff, yeah. More staff costs because of more time. Abnormal payment plan, maybe. Well, just look, there's loads of things. You just need to get one. So any of these will be sufficient. I think if you make any logical sense at all, that'll be fine. And that's that question done.